So in this video, I want to do an example of just sort of thinking through a free body diagram that involves both torque and force. And since I like to bike, I'm going to do something that has to do with a bicycle. So we'll think about a bicycle, and in particular, I'm going to think about just the rear wheel of the bicycle. Okay, so I've got the frame here, but the frame is not part of the system. There's, of course, the rear cassette on the wheel. There's a chain that is coming off of that rear cassette, and then the bike wheel sits against the ground. Okay, and I want to define my system for this as being just the bike wheel and the rear cog. Okay, so I'm going to sort of chop the bike wheel and rear cog out of the rest of the universe. So here's the wheel, and here's the rear cog. And I'm going to ask the question, what are the forces and what are the torques that are being applied to this system? Well, so one thing that pretty clearly is the case is if I've got, someone up here who's trying to get started pedaling, right? So they're applying some force here, that's in turn pulling on this chain. There's going to be a force on the chain, right? So the chain is pulling forward against that cog. There's going to be the connection between at the axle to the frame right here. There's going to be some force that the frame exerts back on the axle, and that the axle exerts forward on the frame. So there's going to be some force that's due to the frame on the axle. Okay. Certainly gravity is going to be present in this system, so I also have a gravitational force acting. And then finally there's a contact point with the ground here, and at that contact point, if this bike is accelerating, it's possible that the wheel is getting pushed against the ground this way, so there'd be a frictional force forward, and there also would be a normal force upwards to the ground, not allowing the wheel to fall into the ground. Okay. Now for this, the way that I've drawn this picture right now, there actually are no torques being applied per se, except for the torques that are associated with the individual forces. So for example, this force chain is going to give me a torque about either this origin or about this origin. The frictional force certainly would give me a torque about this origin. If I were choosing this as the origin, the force of the frame on the axle would give me a torque. So there will be a number of torques present, but they're torques that are due to the forces. So let's think about choosing an origin here and then figure out what our torques are. And I'm going to propose that we choose the axle as the origin, just for the sake of choosing something. If we choose the axle of the origin as the origin, let's think about what the different forces are, or what the different torques are. So we first of all got the torque due to the chain, right? The torque due to the chain, if I've got some distance here that I'll call little r, that's simply going to be r times F chain, and that will be in the negative k hat direction, because you can see that that's going to tend to cause the wheel to rotate clockwise, right? The frame force is going to give me 0 torque, because if I choose the axle as the origin, that's actually a force that's being applied at the location of contact. The gravitational force will also give me 0 torque, because that force is also applied at the center of mass, which is the location of contact. The normal force will give me 0 torque, because the radius, the position vector that goes from the origin to that point of contact, is anti-parallel with the normal force, so that cross product will give me 0. On the other hand, the frictional force will give me a torque, which will be simply the radius of the wheel times whatever the magnitude of the frictional force is in the k hat direction, and that will be a positive torque, right? That's tending to cause the wheel that would like to cause the wheel to rotate counterclockwise. Think about what I just said. The frictional force would like to cause the wheel to rotate counterclockwise. What is actually going on with that? Well, what's going on with that is that the total torque, if this bike is accelerating to the right, the total torque on this has to be less than 0. It must be negative. That is to say that the frictional torque, the torque due to the chain, has to be larger than the torque due to friction. Okay?